Today I want to fix this inverter. I want to cut the processor side of this inverter board. This is Genius inverter. I think Genius. So Genius inverter. So the board is working. The board is not working properly again. So but the MOSFET side is still okay. This is the MOSFET side. This is the MOSFET side. This is the control side with the processor. And this side is the control side. Why this is the processor? So we want to cut off the processor side and replace it with this board from ABSO technology. So I'll be explaining in details how to do this easily. So if you have access, you can contact ABSO technology to get this board. It's readily available with ABSO technology. So just contact us. So I'll be explaining how you can collect it to this board in case you have an issue with this type of inverter and you want to replace the processor side. So let's start now. So let me remove the LCD. This is the LCD. Let me unscrew it. So I've unscrewed the LCD. I'm removing everything on board now. Now let me. So instead of this LCD now, we use this to replace this one. So the difference is that this board can communicate with this solar board. Although this board can use up to 9 different LCD. So this one can work with up to 9 different LCD, custom LCD. So, but since this is the type of LCD this inverter is using, you have to replace it with this one. So that's just it concerning the LCD now. So now let me put it on the side. Let me unscrew the camera.
Okay, pause it.
So this is the board now. So I want to cut it now. So let me place it down. Temperature sensor now. Remove the temperature sensor. So this is the board now. So at this stage now, so this board, this what is actually assembled here. This is the MOSFET transistor. Sorry, okay. This is the MOSFET transistor 1, 2, 3, 4. So 4 set of MOSFET on this heatsink. All the 4 units here, 1, 2, 3, 4, act as a single MOSFET. The same thing applicable to this. They act as a single unit. 1, 2, 3, 4, act as a single unit. The same thing applicable to here. 1, 2, 3, 4. They act as a single unit. The same thing applicable here. They act as a single unit. All the 4. So if we now count the total unit now, we now have 1, 2, 3, 4. So the same thing applicable here. Q1, Q2, Q3, Q4. So those are the MOSFET. Now this Q2 is this one because this is the negative, battery negative. So clear. This Q2 is this one. Then this Q4 represent this one. Then this Q3 is on the top of Q4, represent this one, which is very on the top, represent this one. Then this Q1 now on the top of Q2 represent this one. So that's all what we need in a MOSFET board. So then the transformer, this is a symbol for the transformer. The transformer will be collected here on these two separate heatsink. Do not forget that the heatsink for this Q1 and Q3 are joined together as a single unit because the positive side is connected to the drains of this MOSFET. Now, what we need is this. To control this MOSFET now, there's some signal we need. The name of the signal is BAO BHS, BLO, ALO, AHO, and AHS. Now, on this board, it is clearly written there.
This one.
So each signal, you just tap a wire from here. This BLO, this signal, this terminal is BLO, you collect it to this BLO. BHS, you collect it this BHS. Then BHO, you collect it BHO. Then AHO, you collect it to this. AHS to this. Then ALO to this. Then feedback for the feed battery, either this or this. Then ground, which is a negative. So that's all the signal you need to interface with this MOSFET now. So we'll start doing this now. So let me trace the MOSFET now. So this wire now, I want to use this wire to interface. So I want to cut off one. You know this board have feedback A, feedback A, feedback B. I want to use feedback A alone. So I want to cut off feedback B so that I will not make mistake. So I've cut it off now. So now this is for feedback, which will go to here. So we'll now trace the feedback, and do not forget that feedback you can tap it for the for this capacitor. This capacitor now, which is this side. So let me tap it. So followed by ground. So this is the ground. Now do not forget, this is the ground after the fuse. So now tap it here. Then these two terminals, we don't need it. Now the next one, which is, let me check it. The next one is BLO. So we are using BLO. So this side we take it as our B, this side we take it as our A. So BLO now. Now locate the gate. This MOSFET transistor have three terminals: drain, source, and the gate. So we collect it to the gate because based on the diagram here, BLO, this is the source, this is the drain. So this is the gate. So we are collecting it to the gate. BLO. Oh, need to go one. So we want to tap it here, which is, so we now trace this wire now. Sorry. This is the wires, this is the track supplying the gate. This is the gate resistor 1, 2, 3, 4. These are the gate resistor. So we'll tap it from here now. Okay. So we have collected our B based on the diagram. We have collected our BLO. Then followed by what? BLO, BHS. That is BHS. So we want to collect it. So the BHS now will be collected to this drain of this MOSFET. So we have to locate it. This is you have to locate it. Source. That's my bridge. Track here is the source. So you can collect it here. You just tap. So you can now collect it here. Then after we have collected the BH source, then the next one is after the BHS, then BHO, which is this. So it will be collected to the gate of this one again now. So let's try and trace it here. So if you look at it, this is the when track supplying the gate for this MOSFET. This is the gate. So this gate resistor, gate resistor, gate resistor. Then we calculate it here. So let me try it now.
Kúrò lórí ẹ̀.
So by now we have collected the B side. So we want to collect A side now. So A start from, let me check it here. We have AHO. So we are starting from here. So now this is the track for this A side now. And this is gate resistor, gate resistor, gate resistor. So we are collecting it to this terminal. Check it very well. To this terminal. Then so we have collected the AHO. So the next one is after AHO is AHS. So then the AHS will scrap this area also.
Tí ó ronú. Fẹ́ kò sílẹ̀ tẹ́ ṣe fẹ́ sùn. Kò sí. Bẹ́ẹ̀ kì í pé fọ́mọ inú òfin bẹ̀rẹ̀. Ó clear.
So now the last one is the ALO, which is to the gate of this one now. Let's try. So we are collecting to this terminal. So by now we have collected everything together. So let's test it with our meter. You have to verify after you collect everything. I will place my meter in continuity regions, continuity mode. So now I will now be verifying this based on this diagram now. So based on the diagram here, I will be verifying the collection. This is my diagram. So this is my diagram. This is the positive. I told you that the positive we collected here. So and the positive is this first terminal. So let me try and maybe it's being collected. So it's reading now. It's making sound. It means it's correct. The negative will be collected here. Let me try. This is the negative. Yeah. So it's working. It's correct. Then the first one is BLO. Now BLO is this, which we collected to the gate of this. This is our B side. This two side is our B side. This is our A side. So the BLO will be collected to the gate of this. This so it's reading. You can see it read. It read. It read. So I try to check that 5 ohms you are seeing. The 5 ohms you are seeing here. So clear. The 5 ohms you are seeing here is the gate resistor. This gate resistor here. That's the value. So the 5 ohms is the, you can see that it's reading 5 ohms. 5 ohms. 5 ohms. It means that our B is collected to the appropriate MOSFET. Then the BH source now will be collected to this terminal. So let me try it. You can see it's okay now. Then the BH source, this one BHO will be collected to this. Let me try it. It's okay. It's okay. It's okay. It's okay. So followed by this one now. AHO. It's okay. It's okay. It's okay. It's okay. Then followed by AHS. It's okay. Then followed by AHO.
ALO.
ALO, sorry. It's okay. It's okay. It's okay. It's okay. So it means the collection is now correct. So that's how we collect the board to this MOSFET board now. Do not forget I will cut it. If you need a MOSFET board, just contact our solar technology. We still have a MOSFET board. So let's bring our transformer. This is our transformer, and this is the fan. So let's mount our board back. So what's my board now? So we have mount board back now. So now, don't forget, this process is possible. So, and this is possible. So you collect this now. Okay. So now, I told you that the transformer, this is transformer, and this is transformer. The primary and the transformer is this. So you collect the source from here, which is this and this. So let's collect it now. So that's how it is. You can so this one, also, this one. So we collect the primary and so now we need the second. Then now, I'm going to collect the brush. So we have collected it now. So now this LCD, this is the fan. Let me collect the fan here. And depending on how you want it, let's look how we can place our board. Maybe like this also. But before that now, for that, this is our LCD. Okay, we can see this. So yeah. So now do not forget that I told you that this processor board can work with up to 9 different LCD. So this one, you want to select it for this processor so that it can communicate with this LCD. So you have to power it through this terminal. Once you power it through this terminal and the processor does not detect any voltage from here, it will enter LCD selection mode. So let me try it here now. So you can see the LCD is just light up, but there's nothing on it. So you now press this button, but you will hear any sound. So then you will be taking the LCD. So you see something following meaningful, something meaningful on the display. So I will press the LCD and you'll be observing I will press the button here, you'll be observing the LCD. So something that is valuable display here, then that's when you stop. So now the LCD is now working now. You can see that it's selected 24-volt system. If I want to select 36, I will press this on shortly. So it's changed to 36. If I want to select 48-volt system, I change it to 48 now. So this 48, if I leave it like this, means these settings will be using 48-volt system. So, but I'm using 24. Let me return it. This was 12-volt system. This was 24. So the board here, the transformer here is for 24-volt system. So I'll now remove this board, this cable now. Then it means I've set up my XCD perfectly now. So now another thing here is we now collect this transformer. Do not forget, based on our diagram here, sorry, based on the diagram, we have a capacitor here. This is the capacitor, bring the camera. Capacitor. Based on the diagram here, this primary terminal is this, has been collected here. This secondary terminal is this two, and it has been collected to the output. To the output here. Then this capacitor is now collected here to the output as well. You can see the wire. So that's a complete system now. So now that's for the containing the capacitor. But we want to connect this terminal transformer to the board so that it can regulate the voltage and can also use the NEPA. Maybe you have mains, you have NEPA or generator, you can use it to charge the battery. So if you look at the board here, so we have transformer life, then the output life. So the life from the transformer will enter here, you solder it. The output wire from the life output will be collected here. Then the neutral from the transformer one, the neutral from the output to the output, and even the input will be collected here. Then the output life for charging, maybe you want to charge with NEPA will be collected here. So that's how you do it. So let's not do it now. So this one is connected to the output. The neutral is connected to the neutral. So the neutral is connected to the output. So now, if you start using the neutral from the transformer is connected, the neutral from the output is connected. So the neutral is not connected. Now the light now. So the light from the transformer, this light from the transformer is connected. So then, this neutral must affect both hands. A bit light must affect connected. So let me take this this is. So now, what happens from here? So the life of plasma is connected to the body, and also connected to the output. Then the neutral is connected to the body, and also connected to the battery. So now we gain life from the supply. So this is life from supply from the NEPA one generator. So we have collected everything now. So this is our fan. Then this thermistor now, we can now use it. This for temperature sensor. So now we have collected our fan. Then our thermistor for temperature sensing, we collect it here to this terminal. So we have finished the collection now. Let's test the system. So we have finished the collection. You can see, okay, the display is now working, showing input output. Then let me turn on my oscilloscope. This is my oscilloscope now. And let me collect it here. So this wire is connected to the Bangui camera. So this wire now, I want to collect my oscilloscope to it. So now I want to start it and see the waveform on the screen. So let me use the on button here to start it. You can see now it's working perfectly. 226. So it's now working perfectly. So it's easy to collect. Just get the board from ABSO Technology. So the board is available at ABSO Technology. Just contact ABSO Technology. You can get the MOSFET board or the processor board. So the processor board is readily available and you can easily collect it and use. So instead of discard your inverter, maybe if the processor board is too bad, so just get the board from ABSO Technology and you can still put your inverter back to life. So subscribe to my channel and watch my video. Save this video for future purpose. And if you want to learn more, comment. If you want me to teach you some things, maybe you didn't understand some terms or some things in this video, just comment and I will explain better in my next video. So thank you.